molar mass is the mass of 1 mole of particles. Among others, these particles can be atoms or molecules. The molar mass is symbolized by a capital M. It is measured in grams per mole. Remember, 1 mole, N, corresponds to 6.022 times 10 to the 23 particles. The atomic molar mass is the molar mass of an atom. In order to determine it, one can simply refer to the periodic table. The atomic molar mass can be found in the element square. It can be below the chemical symbol, or, in our case, in the top right-hand corner. In the case of the carbon atom, the atomic molar mass is 12.01 grams per mole. In other words, 1 mole of carbon has a mass of 12.01 grams. For the oxygen atom, its atomic molar mass is 16.00 grams per mole. We can also say that 1 mole of oxygen has a mass of 16.00 grams. The periodic table is also the reference for determining the molecular molar mass, which is the molar mass of molecules. Let's determine the molar mass of carbon dioxide with the formula CO2. This molecule is composed of 1 carbon atom and 2 oxygen atoms. The molar mass of carbon dioxide is therefore the sum of the molar mass of carbon and 2 times the molar mass of oxygen. Therefore, MCO2 equals MC plus 2 times MO, or 12.01 grams per mole plus 2 times 16.00 grams per mole, for a total value of 44.0 grams per mole. Molar mass is measured in grams per mole, which comes from dividing mass by the number of moles. The mathematical formula for calculating the molar mass is therefore large M equals small m over n. By isolating n in the formula, we also find the equation n equals small m over large M, which allows us to calculate the number of moles. Let's use an example. In order to produce heat, 250 grams of methane are burnt. Given that the formula for methane is CH4, how many moles of methane were burned? By calculating the molecular molar mass of methane, we will know what mass corresponds to 1 mole of methane. Then we can determine how many moles corresponds to 250 grams. Let's go. A methane molecule consists of 1 carbon atom, C, and 4 hydrogen atoms, H. Referring to the periodic table, we can see that their atomic molar mass is 12.01 grams per mole for carbon and 1.01 grams per mole for hydrogen. The molar mass of methane, CH4, is therefore MCH4 equals MC plus 4 times MH, or 16.05 grams per mole. Now the molar mass and the mass of methane are known. The formula N equals small m over large M can be used to calculate the number of moles of methane. We place the values in the formula and obtain an approximate value of 15.6 moles. To answer the question, the 250 grams of burned methane corresponds to approximately 15.6 moles. The molar mass allows us to calculate the number of moles of a substance from its mass. Conversely, the molar mass could also be used to calculate the mass of a substance from its number of moles.